Alright dudes, it is time to solve number 9 on chapter 12, Physics B AP. Number 9 reads, 1 mole of an ideal gas initially at temperature initial equals 0 degrees Celsius undergoes an expansion at a constant pressure of 1 atm to 4 times its original volume. A. Calculate the new temperature final, of the gas. B. Calculate the work done on the gas during the expansion. So let's get started. So here's what we know. The temperature initial equals 0 degrees Celsius. You're going to want to convert this into Kelvin. That's 273.15 Kelvin. We also know that it remains at a constant pressure of 1 atmosphere. We also know that the final volume is going to equal 4 times the initial volume. Let's go ahead and write the combined gas law. Pressure 1, volume 1, over temperature 1 equals pressure 2, volume 2, over temperature 2. What's really great about this problem is that the pressure is kept at 1 atmosphere, so we can eliminate that from the equation. Then, using these variables, we can plug in our givens and find the final temperature. So let's plug in what we have. Volume initial over temperature initial, which is 273.15 Kelvin, equals volume final is 4 times volume initial, so 4 volume initial over temperature final. 273.15 Kelvin times 4 volume initial equals 1092.6 Kelvin. Our book is going to be all fancy about it. They write 1.09 times 10 to the third Kelvin. And that is your answer for part A. Part B asks us to calculate the work done on the gas during the expansion. For this part, we will need the work equation for gases. Work equals pressure delta volume. Well, this is a problem because we're not given an initial volume or a final volume. We only know the magnitude. So that's kind of lame, but we do know something else. Pressure delta volume equals NR delta T. Whoa, wait a minute. Pressure delta volume and pressure delta volume. Whoa, I think we're onto something here. Work equals NR delta T. So with this equation, the only thing we don't know is that delta T, but it's very easy to find it. We know that in the beginning, it started off as 0 degrees Celsius or 273.15 Kelvin. And then from there, it went to 1092.6 Kelvin. And we found that 1092.6 Kelvin in part A of this problem. The difference between those two numbers is delta T equals negative 19.45 Kelvin. Just to restate the givens, N equals 1 mole, and that was given to us in this problem. And R is a constant, 8.31 joules over mole times Kelvin. This is all we need. That was kind of a terrible circle, but that's all we need, and we can plug all of that into that equation right there and get the answer. So I rewrote the equation here. Work equals NR delta T, and then I plugged everything in. Work equals 1 mole times 8.31 joules over moles times Kelvin times negative 819.45 Kelvin. The answer is then negative 6,809.63 joules